Let's see if we can figure this out, because I think you can. What would you do? What would you do if the whole problem was this? If this was the problem, if that's all we had, what would you do with that? Loop-de-loop. So you would say 10 to the 0 equals x plus 3, right?
Yeah.
No question. But the problem looks like this. So what if we loop-de-loop the outer logarithm? What would it say? 10 to the 0 equals log x plus 3? Is everybody okay with that? Exactly like this. We just have a quantity in there now. So what's 10 to the 0? So 1 equals the log of x plus 3. Now we can put our base in there again and loop-de-loop one more time. So 10 to the first equals x plus 3. So that problem, this is what problem I, the answer is 7. We okay with that? All right, I want you to get started. I'm going to have you come up as you work through it. And we're only going to be able to do a few at a time because I got to get it on video. So maybe we can get 4 at a time up here. As you work through them, if you feel comfortable, come up and put yours on the board. And we need to use black markers, please, because they show up the best. Yeah, we're only going to be able to do 3 at a time. We can only get 3 up there.
Oh, D's
You
going.
can do D next round. We'll get these 3 discussed and then you got D.
Alright.
I can't get it all on video.
You should do I.
I?
I already did I.
Yes. Not a lot, man.
That's right. That's right.
He's got D. It's his compliment.
He knows this.
right, how are we with number 1? Are we, everybody get 2?
Uh-huh.
No questions? You need to ask if you have a question. 2 is what we got? All right. Have you all gotten to number or letter B? When he solved it, he actually got 6 and negative 6. But not only can we not take the logarithm of a negative, the base can't be negative. The base has to be a positive number. So he said my only answer to B is 6. Good?
Yep.
Did you get this far yet? This turned out to be a little quadratic, which factored. And we could only take the positive answer because x can't be negative 4. So he got 8, or she got 8, whoever did this got 8. Last call for A, B, and C, we're good? All right, let's get D, E, and F at when you're ready. Answers, one of them should have been positive and one negative, so.
Where's on J up? So we're removing 5 to x on it.
It would be multiplication, but I wouldn't do that. I would subtract.
Well, yeah.
one.
Oh, that's smart.
That's what I would do.
Kellen, what do you need?
What?
You good on J now?
Yeah.
Let's get 4 for F. F?
You done too? All right, for D, most of you are really cranking through this. You're amazing human beings. For D, we got 3 up here. And for E, we got 1. And for F, we got 4. Okay? Now, before we move on, and you're done, I want to talk about the difference between D and F. Now, D and F both ended up being quadratics and both got 2 different answers. Did you notice that in D, they said use the positive solution only, but in F, they did not say that. And here's the difference. If this problem were part of this exercise where the answer had to be a whole number, -4 would actually be an okay solution to this problem. It's a legit answer. Because if you put -4 back into the original problem, doesn't this turn out positive? So if this were a test question, it would have two answers, -4 and 3. Both are okay. This one, on the other, so they had to tell me, don't use the negative one, only use the positive one. On this one, my two answers were -5 and 4, but could -5 even be an answer to this problem? No. So that's why they didn't tell you to take that out. You were supposed to be smart enough to take it out on your own, because it can't be. Does that make sense? So again, -4 would be an answer to this question, because it checks. Okay, what do we got? That's D, E, and F. So we have G, H, and J. All right, do we have volunteers to put G, H, and J?
Can you erase that?
So G, H, what is it, J?
Prove him wrong.
We can do one.
Let's go. You have that already, Cole? You're awesome.
So, like,
If you are done with all of these, go ahead and get out a sheet of scratch paper, because you're gonna need it. I mean, like a loose leaf,
and the wings one.
because the review sheet I made, you're gonna need another sheet of paper. You can't do it all.
So good looking video.
2.9 and 2.15.
Just where you found the bed.
14 and 15
It usually has some.
more rhythm, progression, and some of them.
You got me on?
What?
You got next speed?
Yeah. This is 4. When is the quiz?
Monday or Tuesday.
Kelly. Oh, I gave him one.
You gave me it.
Did she say Tuesday? Yeah.
Sunday I don't see. When do I not see you? Tomorrow? Alright, so I see you Friday and then I'll see you Tuesday. Yeah. Okay, so G we got 0. H we got 5 up there on the board. And so did I. And J looks like we got 9 for J. J is another one. Well, actually,
The answers can't be negative.
it tells you here. Positive solution on that. That J is another one, you guys, that if this problem were just happening on a worksheet somewhere, the answer would actually be plus or minus 9. Because -9 works in the original equation. Be careful about that. I know I've been hammering this whole idea of extraneous roots, but not every negative is extraneous. You've got to put it back in and see. Alrighty? Okay, good work. Did you use every digit once? Did anybody keep track of that? Okay, good. That was our goal. Alright, let's see. Okay, now I got a worksheet for you. You need to do this on your loose leaf because I tried to conserve paper and kind of crammed it all on.
No writing on it?
No, you can write on it, it's your
Oh.
paper.
I thought
There
you were
just isn't enough room to actually do the problems. There might be room to do some of them, but most of them you're gonna have to, okay.
Oh, my.
Cool, let's quit thinking about days off and start being days on
I
here.
was thinking about the anti-racism that he sounded like he was fighting racism. Pro tip. Pro tip.
Let me just tell you, math is probably the farthest subject away from that.
No. Probably actually.
Oh, math is.
Anybody know what's significant about today?
What's the date?
Today's the 15th. It's actually Martin Luther King's birthday. Today is his legit birthday. But it's also one of my brother's birthday is today. And you're thinking, okay, Mrs. Ford, that's awesome. Why are you telling me this? Well, my brother, Eric is his name, was born on the first Super Bowl Sunday. So on January 15th, 1967, was the first, my brother's 58 today, was the first Super Bowl. And my dad never let my brother forget that, because instead of watching the first Super Bowl, my dad was at the hospital with my mom having my brother. So anyway, interesting, fun fact, look it up, it's true.
That's actually crazy.
It is crazy. It is crazy. Okay.
You were hyped for it though?
I know that everybody in the room knows how to do the first problem, and in fact, some of you may already have it done. But I noticed last period, because we started this sheet last period, that we were having some confusion getting a common base. So let's not be confused. What's our common base between 9 and 127? 3. So 9 is 3 squared. Now, what power of 3 is 1 over 27? Negative 3. Very good, Landon. Negative 3. Why is it negative 3? Because anytime you have 1 over, you need a negative exponent. That's what negative exponents do. Last period, we were putting in fractional exponents. No. What do fractional exponents do? Roots, right? I don't want any roots in this problem. I want a 3 to a power. So negative 3 is my exponent. All right, go ahead and solve that. What do we come up with? Okay, I got negative 110, but I don't know, is that right?
Yeah.
Now, is it okay to have an answer like negative 110? Totally okay, because x is an exponent, and exponents can be anything, right? We don't have any issues with that.
So that negative 3, we just throw the negative out front.
We multiply these?
You're just taking the exponents.
Oh, okay.
You get rid of the base.
Yeah, I kind of did that in my head, yeah.
Yeah, okay. Oh, yeah.
So this gets multiplied.
I forgot to get rid of the bases for some reason.
Brother, I went to the board. No, one of the things I went to the board. That must have been scary for you.
Okay, all right, try B. I'm gonna go ahead and do it up here while you're doing it.
Wait, what did I do?
I didn't do this ahead of time, so I have no idea. This is what happened for me. What happened for you?
That's what we got to.
That's what you got too.
Like all of that.
Can that be an answer? No, because what happens over here if we put in a negative number here? Isn't that gonna end up negative? So it isn't gonna work. That answer isn't going to work. It could work, negatives can work, but this one won't work right there, so. Anybody have a question about that one? Are you starting on 3 or C? Good. C's a big one. So go ahead and get started, see what you can come up with.
She said it can be, it's not the, and then she pointed to this part because it doesn't go in here. Like, oh, this side can't be. Oh, yeah, it's the long. Yeah. So it would have, so whatever's in the 16 should get that option. And then nothing can go past negative.
I got go do the number line.
Negative 1, 4. Positive. Positive. So nothing can go past negative 1.
Yeah. So all of those 2 points are graphing.
This is one of those logarithmic inequalities that are kind of just big. There's just lots of things to think about. So the order you think about things doesn't really matter. I started out looking at my individual things I'm logging. And I know that whatever is in those circles has to be positive. Right? So that means x has to be bigger than 1/4, and x has to be bigger than -1. Now that's an and. So I gotta be bigger than 1/4 and bigger than -1. So doesn't that mean I'm bigger than 1/4? So I'm not even putting the -1 on there. You could, but it's gonna be wasted work, because no way is it gonna work, okay? Nothing down there is gonna work. So there's my 1/4. That tells me this problem is starting at 1/4. So then I took my problem here and I pretended for a moment that it was an equals. So I went ahead and divided these two things and set that equal to 6. Now, does that bother anybody? Did I skip a step in there that bothers you? And then I solved this, and if I did it right, I got 4. So that's another dot on my number line. What was that? Okay, now you guys, if the problem had been or equal to, then that 4 dot would be colored in. But it wasn't, so it's gonna be open also. So bottom line is, you've got 2 sections to check now. So if we put in a number like 1, it says the log of 6 minus the log of 2 is less than the log of 6. Now, what does your common sense tell you? Is that true? If you take the log of 6 and subtract something from it, is it gonna be less than?
Yes.
Yeah? So this is gonna work. Now what if I put in 5? Well, then it's gonna say the log of, what is that, 38? Minus the log of 6 is less than the log of 6. Now, before you get confused about this, remember, these two numbers are going to get divided. So this is the log base 4 of 38/6 and the log base 4 of 6. Is this number bigger than 6 or less than 6?
Bigger.
So that's not true, is it? Because this is 6 point something. So that doesn't work. So the only answer to the problem is the interval from 1/4 to 4.
Why don't we check like from 1/4 to 0?
Somebody tell him, we already talked about that. Why don't we check?
Because x has to be bigger than 1/4.
You can't take the logarithm of a negative. So that has to be positive, and the only way that's gonna be positive if x is bigger than a 4.
Thank you.
And that trumps everything. Your domain is big. Is that okay with everybody? All right, what about D? What do you think about D? Ben, what do you think we might want to do first here with this guy? What would you do if you found this? Move the 3 over, sure. Now, Bennett, I know you got an idea.
Divide by 5.
Divide by 5, absolutely. Now what are you gonna do? Get a common base. And what's your common base gonna be? 2? Now be careful. You're gonna change this into 2 to a power. 1 over means that power has to be negative. And since 4 is 2 squared, negative 2. Equals 2 to the first. Negative 4x plus 2 equals 1. Did you get 1/4? No? You didn't?
I'm starting to think I'm wrong.
I got
Negative 1/4?
No, there's a negative on the top and the bottom.
So it's negative 4x plus 2, and then 1 over there. So when I subtract, I get a negative 1, and then I divide, it's going to be positive. Right on?
Yeah. I found my mistake.
On your mistake.
That's right.
Stuff for D?
Yeah, Kelly, yeah.
Quality.
Oh, it's an inequality. Oh, shooty tooty. I'm sorry. You're right.
Oh, so
I just solved it too. I was having a good time.
I just solved it too. All right, so where did I get up here? Wait, am I dividing by negative? I am. I need to be careful. So negative 4x plus 2 is greater than 1. So did you get less than 1/4?
Yeah.
So I gotta write my answer then as negative infinity to 1/4.
Yo, what? I don't want.
Thank you for pointing that out.
That's why I was asking. You got me wrong.
Here, you got some
Kelly was cool.
Nope,
I feel like that's the exact opposite.
there's no, you're not doing a sign chart, you can't do a sign chart, it's just a single inequality. There's no dots to worry about.
I literally, he probably thinks the
Okay.
without imagining snakes.
All right, what do you think about number
He
2?
doesn't know where baby's
Number 2. What do you think about this
Is
thing?
that an 8? Is that log 8?
I think it's a, yeah, it is. I think it is an 8. Yeah.
What?
Are they both log 8x or?
No, one's an 8, one's a 3.
I know you could.
So we have log base 8 of x, and we're gonna write that as something times log base 3 of x. Remember what a vertical dilation means. A vertical dilation means a stretch or shrink this way, and that's accomplished by a multiplier. As opposed to a vertical translation, which is pick it up and move it, and that's accomplished by adding or subtracting something at the end. This is a vertical dilation. Alex,
How do we figure out which one has the check?
what?
How do we figure out which one has like
Well,
the variable?
it says, write this as a dilation of this one. So I think that means we're gonna multiply this one by something, and it's gonna generate that. Okay? Now, this is way easier. I mean, I can tell by looking at it, you're either tuned out or you have this horror-stricken look in your face. This is way easier than you think. Remember your change of base. Remember that if we have any logarithm, like if somebody for some reason needed the log base 3 of 5 on my calculator, which doesn't have any special buttons, I can change that base and say, okay, this is equal to the log of 5 over the log of 3. Remember that? That's kind of an important rule to remember. It's called the change of base formula. And it's always this one, the log of this one, over the log of this one. But the beauty of it is, I mean, I automatically went to 10 because my calculator has that button. I could have automatically gone to ln. These are equal. All these things are the same number. So in this problem, I'm not looking to type it into my calculator. I want to change it from this into that. So what if I rewrote this as the log base 3 of x over the log base 3 of 8? Do you see I'm doing the same thing? Instead of saying log x over log 8, which is what I would do if I'm typing it in, I'm saying I'm going to use base 3. Why am I using base 3? Because that's what the problem says I need to be using. So log base 8 of x is this. Log x over log 8, any base you want. And another way of writing that is like this. Would you agree with that? So there's your answer. There's your answer. That's all there is to it. It is really easy. So let's do another one just to make sure that that's solidified
I thought that was pretty easy.
in your head.
Looked at that problem and I was like.
Let's write log base 7 of x as a vertical dilation of log base 13x.
We just have the denominator, which is just.
Okay? So start right here,
This equals.
rewrite that. That is always going to be able to be rewritten as log x over log 7. That's a formula. Always you'll be able to do that. The base you choose is completely up to you. I've got base 10 up here now, but I could use any base in the whole wide world. Well, what base would it make sense to use? 13. So I'm going to put base 13 on there. And then I recognize that that's 1 over log base 13 is 7 times the log base 13 of x.
When do you like set them equal and then divide the two by each other to find k?
there's one, like, you know what I'm talking about, because like, one time we would solve for k, and that would be equal to, like, for the log 8 and log 3. One time we did that, and it would be like log,
Okay,
base 8
so
of x.
let's talk about this for a second. So basically, this is K. Would you agree with me?
Sure.
Well,
You wanna change the.
I'm writing log base 7 of x as a dilation. That means something times log base 13 of x. So isn't that my K,
Oh, okay.
right?
Yeah.
And so then, if you got a calculator that does that, you're all set. I'm gonna have to rewrite this then as log 7 over log 13. And 1 over that is gonna be my decimal value, if that's what you're talking about finding. So, I'm not sure. There's lots of different ways to do a problem, so this is what makes sense to me right now today. Maybe I did it differently before, I don't know. I have to go
Yeah,
back.
like we set the two things equal, and then we divided, like the.
If that, I'm not quite following that, but if that makes sense to you, just make sure you're getting the same answer. Now, it may look different. It may look different, because it may be some version of, log 7 and log 13, but it should be the same. I'm happy to look at it to make sure. All right, number 3. Let's talk about what this thing even looks like. Let's start at the beginning. What does a logarithm, just a regular old basic logarithm, look like? It has an asymptote at 0 because x has to be bigger than 0. It has an intercept at 1, and it looks like this. Now, this is not what the problem looks like, but that's your basic logarithm, right? So let's talk about now what has changed if we put an x minus 5 in parentheses. What does that do? That part right there. Moves it to which way? To the right 5. So instead of the asymptote being at 0, the asymptote is now at 5, and the intercept is at 6. So that takes care of that. Everybody get there? What does that do? That's gonna make it upside down and steeper. Now, in terms of end behavior, the steeper part doesn't matter, but the upside down part matters. So now it's gonna look like this. Would everybody agree with that? When I write my end behavior, is this f of x? I am programmed to use this notation. This is my normal, standard, regular end behavior notation. X approaches infinity, x approaches negative infinity. But with a logarithm, that won't work, because x is never going to approach negative infinity, because it has that asymptote stopping it. So this isn't going to be negative infinity, it's going to be not 0, 5. For our problem, it's 5. For the regular logarithm, it would be 0. But for our problem, it's 5. Does that make sense to everybody? This will be an easy place to miss points if you're not, thinking clearly. All right, well, what happens to the right? In that picture, what's happening? We're heading toward negative infinity. What's it doing on the left side, toward the asymptote? Positive infinity. There's your end behavior. Does that make sense to everyone? All right, 4, A, and B. These might be the last two to get done. We have practiced these within the last, couple days. So I'd like you to do 4, A, and B. And then we will be prepared to have them put on the board. You're finding the inverse. So remember your steps. Feel free to tack up by yourself or with a partner if you don't want to come up by yourself.
Yeah, we already got it done.
No idea?
You do this for a while, do it on paper, you can do it on the board.
Do big.
I'm about it.
what's
We're gonna see.
Yeah, let's see that.
Yeah, I'm probably gonna be stumped, and then I'm probably gonna be like, yeah, I have no idea what I'm doing.
We're just gonna go, oh, this.
Are we doing that?
Sunday nights, Tuesday
Do today, buddy.
It's due Thursday.
This is for,
Hey, what days are homework?
is the homework due today?
tomorrow.
Or
Oh, yeah, he's a
2:13
good
is
student.
tomorrow.
See?
Enzo, I beat your car in a race on foot.
Do what?
I beat your car in a race on foot.
You're actually right now.
Oh yeah, that,
Things out of commission.
Can't just not run.
No, it's actually not. I get it.
Hey, cool, focus. Focus.
I'm locked in.
Wait, why couldn't you just log
Regular?
Could you put that in a log? Is that what you're thinking?
Shut up!
It'd be log. Mom, actually.
That's surprising.
It'd be log. She didn't. I sent her the link. I don't know.
Oh, I think this is one of the where this side keeps
So like
it
a week
long.
before Christmas.
It's the old
Right?
panel.
It is, I forgot it.
She's like, radar to paper.
Yeah.
They're like, you can get ones that are like, you can get like laser jammers and shit for the uniform for like $5,000, and then you're like, they can't, the cops can't even like, the radar to paper tells you that the cops are trying to get your stuff. The laser jammers just keep the cops from getting your stuff.
That thing is hilarious.
Like
the whole thing.
It's
You log the.
it's like an SUV. And like he said he likes to do it because he messes with people
log base.
all the time. And have radar
Well, I love
detectors.
these two.
Or
He
log
just
base
flips
plus.
it and then
It just scanned
Oh,
it.
you're right.
And then,
yeah,
this.
like they
So
can't
that
see
mounted down
that
there.
he's still scanning them.
Oh, you write it up
anymore.
there.
My dad probably.
No, that's
saw
not
about
true.
that.
No, wait, yeah, there's no log on that side. It'd just be one, right?
No, it'd be 1 minus 1, log 5, 5, and then you cancel it out.
Yeah, but you don't even need to write it.
It tells you
And then you
what
get it. But that keeps the log, right?
I think our gun is not the thing that's on the dashboard. It's a mounted truck. It's on like the dashboard of a.
I know the like the big box that just sits on the dashboard. It's always That's what, like, if the detector says you're gonna see it's kind of okay, like, you have room to slow down a bit. If it says L, which means this means like they're pointing down at you, you're so fucked.
Because that means they're solely pointing at you.
The cop is literally pointing at you, he knows that.
Well, so that you be like sitting still on the side of the road.
If they're using,
But if they're driving, they just have
They have like
Wait, they count that shit, Rob?
and then that's like.
well, for a second it kind of looked like it, but like it's the white
If
thing
you
on
get that,
too.
that usually shows like
It's the white thing.
So it's like there's K,
Are
K.
they able to get people that are passing them too? If they're going, can they get, if they're going north, yeah, yeah, yeah.
Alright, let's see.
What about on like a big median and there's trees and stuff and there's two
What do we
like,
think
like,
about
busy
problem A?
valley.
Who did A, by the way?
Cool.
Cool? I like all these steps going, really, very careful about your work, good job.
We didn't write black.
So first thing he did was switch his variables, cause that's what we do when we find inverses. And he subtracted 7 divided by 3. He left it this way. This could also be written, this one wouldn't be as nice to rewrite, but 1/3 x minus 7/3, that's okay too, it's okay like this. And then he looped-de-looed and added 2. Anybody have an issue? That looks good. That looks good. Alright, let's see how Owen did.
Kellen and
Kellen and Owen, the dream team. They switched their variables, added 4 and divided by -2.
should be a negative.
Should that be a -1/2?
Yeah. That's my goal.
It's alright.
I think.
And then, log base 5, both sides. That went away and they were left with y minus 1 equals log base 5 of their thing there. Then they added 1, that looks good. That looks good. Now, you might be concerned, this looks like it's negative, but what about that x there? Could that x be a negative number? And that would turn that into a positive, right? So that's okay. By the way, that kind of logarithm when x has to be negative, remember when you change, this is your regular logarithm, what happens when you change the sign on x? When you change the sign on x, you reflect this way. So see how those x's are gonna be negative now? Over here? Okay, anybody have a problem or an issue with that? All right, number 5 has way too many parts for us to do right now. So we'll do 5 and 6 next time. I'll answer any other review questions you have next time. And then we'll take quiz B next time.